Hi, and welcome to this part 3 of our little quickie video number 21, which is a repair job. And we're going to we're repairing my nephew's drill press by producing a new link between the table and the column. And here's the part that we've been working on, and more importantly for right now is here are two 1/4 inch tool blanks, lathe tool bit blanks, that I'm going to be using as parallels, because I don't want this part to sit in the bottom of my vise completely. I want to lift it up a little bit because I don't want to drill into my vise or bore into my vise when I produce that large hole, because that's what we're starting with, producing our 1 inch 850 thousandths hole. I'm using these small parallels for two reasons. First off is I'm going to have to place them contrary to what I would normally do. That would be to place them parallel to the jaws. I'm going to place them perpendicular to the jaws. And for that, well, my parallels have to be a little shorter than the width of my part. And these, well, they're just great for that. Secondly, is this vise is quite small. And if I lift the part up too much, I won't be able to grab it or hold it above the center line of the part. And if I don't grab it above the center line of the part with the vise jaws, well, I won't be holding it very well. And since these are quite short, 1/4 inch high, well, it'll permit me to hold my part properly even in this small vise. So let's get our safety glasses on and get to work. I'm going to start here by installing my piece roughly. Why roughly? Well, because right now the only thing that I need this part installed for is to set the height of my tool, because I'm going to be using the longest tool method here. Why all the kerfuffle? Well, because you have to remember these round column mills lose their alignment if I move the head during an operation. And we've spoken about this in a couple of other little quickie videos that you can go and watch if you want more information about aligning these machines. And that means that we're going to use here the longest tool method that was described in those videos. And for that, well, I have to set the height of the part and the height of the head to the longest tool when the quill is up as deep as possible into the machine. And that's what we have here. We have the tool that is the longest set up in the machine with the quill up as high as possible. And as you can see here, well, we clear the part by a little more than 1/4 inch. I want some play here. So that means that we're set up for the longest tool. All the other tools being shorter, well, their operations will be performed with the quill slightly lower down. But I won't have to move my head. So that being said, and my head being adjusted, we can now take all this out of the vise and change this tool over to the drill chuck, because I'm going to be inserting my edge finder to start finding my references on this part. But oddly enough, my reference in my y-axis isn't going to be found with the part in the vise. I'm going to be using the fixed vise jaw. Very important, not the movable jaw, but the fixed jaw as a reference here. And it's going to be a lot easier to edge find that jaw than it is to edge find this cylindrically shaped part. So that's a little trick that people don't always realize they can do to get their center in the Y on a cylindrical part. And then, well, we'll be finding our reference in our X. So let's get to it. Okay, I'm set up here ready to do my edge finding on the fixed jaw of this vise. I think it's important to mention here that if you don't know what edge finding is, or what this type of tool, this is an edge finder, but there's many ways of finding edges. If it doesn't ring any bells, well, maybe go and take a look at this video that I produced about edge finding. It would be a good thing to do to help you to understand what's going on here. We're going to edge find this jaw and set ourselves to 0 so that we can come back to the center of the part that's going to be installed in this vise. So let's find that edge. So there, the side of my edge finder is even with the side of my part. So now I can set my scale to 0. Now, once that's done, I have to move ahead 100 thousandths of an inch because my edge finder is 200 thou thick.
So my tool is directly above the edge of this fixed jaw. And since the vise is properly aligned, we did that in our other video, well, that becomes my reference for the Y direction. Now, my part here measures 3 inches, and I want to find its center. So its center is going to be 1.5 inches from the edge that I've just found, and I've positioned as being my 0. So all I have to do is crank 15 turns, because on this machine each turn is 0.1 inch. If I want 1.5 inches, all I have to do is crank 15 turns to get to the center of my part. No. No, 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 no. There's a little problem here that's called backlash. And if you don't have a digital readout, like I do not, well, you're going to have to deal with the backlash. And it's not a big problem. If I come in the opposite direction from the direction I was moving in when I found my 0, well, the backlash suddenly appears. Everything has to be done in the same direction. So I found my 0 with my table moving in this direction. I'm going to have to come up to the middle of my part, the 1.5 inches, with the table moving in that direction. Well, that doesn't make sense because I have to move in the other direction to get to the middle of my part. Well, it's simple. Move a little more and come back. I want 15 turns. Well, I'm going to go 16 full turns and then come back to my 0 on my 15th turn in the reverse direction. So I'm going to back up 1 turn to get back to my 15 turns, and that'll mean that I'll really be at 1.5 inches from my reference surface. No backlash problem there. Now, if this really is phasing you, it's a crucial subject. And I do have a video on that subject where we looked at positioning holes accurately on mills in X and Y when you have no digital readout. So maybe take a few seconds to go and see that. For us, well, we're going to be cranking 16 turns. So there's my 16 turns back to 15 so that I approach in the same direction. And that means that I should be on center. I say I should be on center because we're always going to check everything that we do. And for that here, well, I'm going to use my digital caliper that I've set at 1.5 inches. And I'm just going to come and verify very roughly if I look to be on center of the edge finder from the edge of the vise, and I do, so that means this is right. Because if I made a mistake here, it's not going to be 1/1000th of an inch, it's going to be 0.1 or 0.2 of an inch if I miscounted my turns. And I can easily see here if I'm 0.1 of an inch. If it looks center with my caliper, it's because it is. Now that is the reference in Y for the hole that I'm going to bore. I don't want to lose it by grabbing or hooking onto this handle. So what am I going to do? I'm going to lock my Y-axis, lock it down solidly because I don't want it to move anymore.
So I've installed my part into the vise and got it to sit properly in the bottom. It's sitting on my parallels. Now I've mounted my edge finder and I'm going to edge find the end of the part. Now remember, the large hole that we have to produce is situated 1 inch 870 thou from the end. So I'm moving 100 thou to find the edge proper, and now I'm moving 1 inch 870 thou from there. Once there, well, I'm going to lock my x-axis, and that is the center of my hole in x and y.
Okay, so I have my 1-inch drill installed in the machine. Now you'll note that I didn't use the drill chuck to hold it. I'm using an R8 collet, and that's so that I could save on height, because I would have had trouble here height-wise had I used that drill chuck to hold it. So this really saves my butt here. So I have my drill set up, and I've positioned it flush with the top of the part by moving the quill, not the head of the machine. We don't move the head anymore. So we're just flush here, and I've positioned my depth stop to 0. Now I'm going to raise this depth stop to 2 15/16 of an inch, and that is what I can get away with without drilling into my vise base. I don't want to do that. So I'm going to go just shy of 2 15/16 on the depth gauge. Okay, we're ready to start cutting. I have some cutting oil here ready to go, but this is going to be a rather long cut here. So we're going to start the cut. I'll cut out, and then we'll cut back in at the end of this cut. Okay, so I have my boring head set up, and we're ready to cut. I haven't moved the table, so we're still on to that center for the hole. Also, I haven't moved the head, so we haven't lost any alignment. All I'm playing with here is the quill. So I'm ready to go. I've set my depth stop in the same manner that I did the last time for the drill, and I've reduced my speed somewhat because this is such a long boring bar that I'm going to be getting vibration. And one way to avoid that is to control my feed, and one way to control my feed, well, is to lower the RPM. And talking about feed, well, here we have the quill snug, not locked, but reasonably snugged. I don't want any vibration here in the quill. And we're going to be using the fine feed instead of the lever here, because I want to control how fast I go down. It's not a question of seeing how quick we can ram this tool through the hole. We have to get a nice feed to get that proper cut. So let's take a look at that. Okay, so we're set up for boring, but this is going to be really boring because I'm taking off approximately 20 thousandths of an inch per pass on the diameter of this hole. I have about 800 thou to take off. So if we do the math, well, we can see that it's going to take 5 passes or 5 cuts for each 100,000. So 5 times 8 is 40 cuts to get this hole to its final diameter. At about 2 minutes per pass, that means that we're going to be having 80 minutes. And 80 minutes, well, is 1 hour and 20 minutes. So that makes for a really boring video. So what we're going to do here is we'll set up our first pass, or our next pass I should say, because we've already cleaned the hole up. So we'll set up our next pass, and then we'll cut out and we'll come back to the end of our last pass. First thing to look at here are these 3 locking set screws, and these set screws close up or tighten up the female dovetail of the head onto the male dovetail of the bottom slide. Now if I loosen these locking screws, this slide becomes quite loose, and it's really difficult to maintain my position cut after cut because I lose where I am. So a good suggestion here is to keep these dovetails as tight as possible, just permitting that you be able to drive the slide forward without ever having to loosen or tighten them. So quite tight but not completely locked. Next I'm going to turn my drive screw at 10 lines in a clockwise direction, and that will push my slide 0.010 of an inch further out because this tool cuts on the radius. Well, what does that mean, cuts on the radius? Well, that means that when I advance this drive screw, my tool actually advances the same amount. I advanced 0.010 of an inch, my tool advanced 0.010 of an inch. That means that my hole got bigger by 0.020 of an inch. Now, as a comparison, we can say that most, not all, but most cross slides on a lathe cut on diameter. And what does that mean? Well, that means that if you turn your dial by 0.010 of an inch, your tool advances half that amount, 0.005 of an inch, but that your part gets smaller by 0.010 of an inch, and that is cutting on diameter. This is cutting on radius. Now, it's important to know, to not get yourself into trouble, that not all lathe cross slides cut on diameter, and not all boring heads cut on radius. So I have my 10 thou cut on the boring head. My spindle is not completely locked down, but it is good and snug to reduce vibration. I've added, or I'm going to add, a drizzle of cutting oil down the side of the hole that I'm going to cut, and I'm ready to go. Now, as I said, this is going to take several passes, and it's going to be quite long. So I'm going to start this first cut, and then we'll come back on the last cut just to see how things finish up. So see you in about 40 minutes. Now that was my final pass, but I don't want to, when I retract the tool, scratch the edge of the nice finish that I just obtained. So what I'm going to do is I'm going to point the tool in the same direction that I'm going to advance the table. I'm going to advance this table just slightly so that it clears the tool. Now obviously I don't want it in rotation when I'm coming up, because I'm going to create, if I did, an oblong hole. So let's unlock the table, move the table forward 4 or 5 thou, and retract that tool. There, this job is done. Well, what's next? Well, next thing, safety first, is going to be a light deburring operation because I don't want to cut myself. And then we're going to do some layout work. I want to lay out a line on the center of that hole that I just produced, a line that I'm going to use to set my depth for the drilling operation that's going to follow. Because then I'm going to be drilling the two holes, complex holes. They're going to be center drilled with tap drill size, then drilled clearance, then countersunk. And once that's all done, well, I have to cut my part in two, and that I'm going to do on the bandsaw because it's just a lot easier to do that way. And if seen as I want it to be nice, well, after that I'm going to come back to the mill and just surface those bandsaw cuts to make everything look pretty. So let's get to it. Let's start by laying out our line. We'll use that to position our depth. Well, as you can see, I have my edge finder mounted in my drill chuck, and I have my part mounted in the vise. And now you can see why those flats were so important to me, because it's really easy here to orient my part because those flat surfaces were perpendicular to my bored hole. It really makes life simple and is a good demonstration of why a little planning can really make a job a lot easier. But if I planned the job out well, I didn't plan this video out very well. We still have a lot to do, and we're past the 20-minute mark, which is my sort of psychological barrier for a little quickie. So that means that there's going to be a part 4 to this repair job. So until then, have fun, be safe, and happy machining.